Section 5.3, Parabolas. Part 1, Introduction to Parabolas. The parabola is a conic section. If we slice the cone parallel to the right or left side of the cone, not going through the vertex, we get a parabola. So we're slicing through parallel to either the right or the left side, but not going through the vertex. The geometric definition of a parabola looks like this. Let F be a point in the plane, so here's F right here, and D be a line not containing F, so here's D right here. A parabola is the set of all points equidistant from F and D. The point F we call the focus, and the line D we call the directrix. So all the points on our parabola are the same distance from the focus as they are from the directrix. So if I look at this point, it is the same distance from the directrix as it is from the focus. And that works for any point on the parabola. The line that passes through the focus and is perpendicular to the directrix is called the axis of symmetry. So that's our green dashed line here on this graph. The point on the parabola that intersects the axis of symmetry is called the vertex. So that's this point right here. And the line segment that passes through the focus and is parallel to the directrix is referred to as the lattice rectum. And that is our purple dashed line segment. That is the lattice rectum. We also have one more definition, the focal length. The focal length is the distance from the vertex to the focus, so this distance right here. That is also the same as the distance from the vertex to the directrix. They're the same distance. The vertex is halfway between the focus and the directrix. The equation of a parabola with the center at 0, 0 looks like either x squared equals 4py or y squared equals 4px, where p we're going to call the focal length, but p is a directed length, so either in the positive direction or a negative direction. So if I have a parabola that opens up or down, then the x is the part that's squared. So x squared equals 4py. If p is positive, the parabola opens up, and if p is negative, the parabola opens down. If I have the y squared in the equation, so y squared equals 4px, the parabola will open right or left. If p is positive, the parabola opens to the right, and if p is negative, the parabola opens to the left. Notice the parabola opens around the focus, and the directrix then is outside the parabola or on the other side. Let's try to graph a couple of parabolas. So we want these equations to look like x squared equals 4py if it opens up or down, and y squared equals 4px if it opens right or left. So the one on the left has an x squared, which means it's going to open up or down. If I divide both sides by 2, I get x squared equals negative 2y. So I know this parabola is going to open down because this is negative here. I know that negative 2 is the 4p from the equation. Divide both sides by 4, and I get p is negative 1/2. So if the vertex is at 0, 0, then the focus is 1/2 a unit away from that vertex, but going down the negative direction. So here's the focus right here. So here's the focus, and here's the vertex. Now to graph the parabola, I could plot more points, just find more points on the parabola, or I can consider the length of the lattice rectum. Now the length of the lattice rectum is this number right here in the equation, the 2. So I'm going to go from that focus, I'm going to go right one and left one to get 2 total, and then I can graph the parabola. So that's how I can get 2 other points on the parabola, is looking at the lattice rectum. So the lattice rectum, remember, is parallel to the directrix and goes through the focus. So if the lattice rectum has length 2, then from the focus, I'll go right one and left one, so I get 2 total. Let's look at the equation on the right. I have 3y squared minus 12x equals 0. If I add 12x to both sides, I get 3y squared equals 12x. Divided by 3, I get y squared equals 4x. So y is the one that is squared, so I know it's going to open either right or left. And this number in the equation, the 4, that has to equal the 4p. So p is 1. So I have a vertex at 0, 0, and then p is 1. So I'm going to go 1 away from the vertex in the positive direction, which in this case is right because the y is squared. So the vertex at 0, 0, the focus at 1, 0. Now I know the length of the lattice rectum has to be 4 because there was that 4 in the equation. So from the focus, I'll go 2 up and 2 down to get 4 total for the lattice rectum. and then I can finish graphing the parabola using those 2 points.